Hello, class A. It's just me, Mr. Wee. So we're down to the last two sections right now. This is going to be 1-9 perfect squares. Why don't you go ahead and write this down? Pause and write this if you need. We're going to be recognizing and factoring perfect square trinomials. This is a trinomial. This has three. This has three terms. And what I mean by perfect square is, will it come out to something like this: 3x plus 2 squared? Like 3x plus 2 times 3x is 2. That's a perfect square. That's not a difference of squares. Difference of squares is where it's 3x plus 2 times 3x minus 2. Like it's like the exact same thing, only the signs are different. This is a perfect square in that it's the exact same thing back and front, and you're going to have it 3x squared. Will this come out to something similar? Okay, so let me show you how to check that. This is one technique that, or one thing that I want you to learn from this section that's really important to me. So first is you just ask yourself, is this a perfect square? And then 16, or like the number at so your A value and your C value are what you're going to check. You have to check the A and the C value. Your A is 9, and then, or your A is the whole thing actually. AX squared, the whole term. Is this squared, or is this a perfect square? And is 16 a perfect square? Your C value. Is this a perfect square? Is this a perfect square? Okay. So let's answer these questions. This is a perfect square. I think it's yes, and it's 3y squared, so yes. And then this would be 4 squared. Very good. So yes, this would be 4. You can take the square root and you get 4. This down here, the only question you have to ask is this term, this root and this root, these roots, 3y and 4 times 2. So let's do that really quick. If we multiply 3 times 4 times 2, which is 2 times 3y times 4, which is 2 times 4, I think is 8 times 3y, that's 24y. If my b value above this is 24y, or the whole thing is 24y, not just your b, but the whole thing is 24y, then you have a perfect square. Let's take a look. Yes, it is. So this checks out. So this is your first step, your second step, and your third step. Okay? It checks out, so you would say, yes, this is a perfect square. This is a perfect square, or just say yes, perfect square trinomial. Again, you're asking if this trinomial is a perfect square trinomial, this one up here. And yes, it is, because I did the check here. Is the first term a perfect square? Yes, it is. It's just 3y squared. Is this a perfect square? Yes, it is. It's 16, and they're all being added together. Okay, there's no subtractions or anything like that. So, and then you just got to ask if this middle term is these two roots combined times 2. And yes, it is. That makes this a perfect square trinomial. Okay, so what that would look like is the final answer. I'm sorry. So it would be yes for 1, and also you would take these roots, 3y and 4, you would just add them together, and then you just say squared. That's your final answer. So that's what the factored out version would be. The question would ask, can you factor this out, and can you tell me if it's a perfect square trinomial? That's what this section is called. Can you recognize if this is a perfect square, and can you actually factor it out? I just factored it out at the bottom, and yes, I did recognize it is a perfect square trinomial. So you don't have to do this, but let's just double check. 3y plus 4 squared is the same thing as saying 3y plus 4 times 3y times 4. And if we just do a quick check, meaning we do the distributive property, 3y times this and 3y times the other guy in the other parentheses, which would be 9y squared plus 12y. And I do the other number here in this parentheses, 4 times 3y and 4. 4 times 3y is 12y, and 4 times 4 is 16. And then you get 9y squared plus 24y plus 16. If this is exactly the same thing as what you have above, then yes, this confirms that not only were you correct in your assessment that it is a perfect square trinomial, but you actually factored it out correctly as well. Okay, this was just a way to check. You don't have to do this for every question. So just do these steps here to answer these types of questions. Okay, now let's do another one, another type of problem. Okay, it's still in 1-9. We're still in 1-9, dot, dot, dot. Okay, and then we're going to go to using or use the square root property. Using the square root property. This is something else that you have to know. So what I mean by this is let's have a statement that's a minus 10 squared is equal to 121, and you must solve for a. I don't think it's really that difficult. I think you kind of already know how to do this already. If you have a square sign and you want to get rid of that square sign because you're trying to solve for a, you just take the square root of this whole thing to get rid of the square sign. The square root of whatever's underneath here and whatever underneath here is squared, they kind of cancel out, leaving you only with a minus 10. But if this is an equal sign, you don't want to change the inherent value from one guy to the other. So whatever you do on one side, you have to do the other side of the square root, or the equal sign. The square root of 121, you would say, is 11. However, please keep in mind, technically, it's plus or minus 11. Okay? And then to solve for a now, you just add 10 to both sides. So technically, your answer is 10 plus or minus 11. So you actually have two possible answers. You have a is equal to 10 plus 11, which is 21, or a could equal 10 minus 11, which is negative 1. Okay? So those are your final answers, but I will be okay with this one as well. Okay? That's another type of problem I wanted you to solve. The last section is, so that's it. Two things from 1-9. Let's do 1-10. 1-10, roots and zeros is what the name of this guy is. Roots and zeros. Okay. So let's see here. This is I think these types of problems will ask you to determine the number of roots and identify what type of roots. Oh, sorry. So this is your example problem. Or no, it's not an example problem. This is an actual topic. Okay, to determine number of roots and how to identify what type of roots they are. So let's give you an example problem now. This is x squared plus 6x plus 9. Okay, few ways you could solve for this. All right, you could solve it with the a times c over b method here to factor this out, which would be your a is 1 times 9, which is 9, and then it's got to add up to, so two numbers I can multiply to 9, but add up to 6. I think it's 3 and 3. So you'd have x plus 3. And the only reason why I can do this and not factor by grouping is because your a value is only equal to 1. If it was greater than 1, I would have to do this. X plus 3x plus x plus 3x plus 9, and then you'd have to group this and this together. But you don't have to do this. You could and you get the same answer, but if your a is only equal to 1, you only have to do just this and just straight to this step here. That's it. Okay? Oh, I see. Oh, sorry. And then the original equation was you set it equal to 0. Okay. If you think about it, this is called a root or a 0. Remember, it's setting it equal to 0. So it's basically asking, when you say equals to 0, it's asking what values of x make this equal to 0. Okay. Well, I would just set this up equal to 0. And then I would subtract 3 from this side and 3 from this side. It would be x equals negative 3. So that's one answer. And the other one, you'd take x plus 3 and set that equal to 0 and subtract 3 from both sides. And you get x is equal to negative 3. Basically, I'm just asking for, in these two binomials, what value of x does it take for this guy to go to 0? And what value of x does it take this guy to go to 0? Well, technically it takes the same thing. So it takes x. So really, you only have one root. You have one root. And then what kind of root is it? Well, to go and answer that question, look at what we just did. Wait a minute, x plus 3 times x plus 3 times x plus 3, that's the same thing as saying x plus 3 squared. This is a perfect square trinomial. Okay, so this is one root, and the type, so you have to determine the number of roots. I did. Okay, now I identify what type of root it is. Well, it's a perfect square root. That's what I just determined. And then the traditional way of doing it, so I just stumbled upon this, like doing just the math I would normally do to figure this out, to solve for this, and I said that's a perfect square root. If you wanted to do the check, here's what you would do. it was just from just a few minutes ago what we just did. It'd be 1x squared plus 6x plus 9 is equal to 0. Okay, well, you would just check to say, hey, is this a perfect square root? Yes or no? Yes, it's x squared. Okay, or just x, the square root of this is just x, and then the square root of, is this a perfect square root? As in, like, can you take a nice square root of this? Yes, the square root of 9 is just 3. And is this 2 times whatever the root is and whatever that root is? So I would say yes, yes. And then this is, yes, this should be 6x. Is this 6x? Yes. This should tell you right away. These 3 things should tell you that this is a perfect square root trinomial. Perfect square root trinomial. You don't have to do this step, but you can. Perfect square root trinomial. I'm just saying at least do the top guy here and recognize that if you have x plus 3 times x plus 3, that's a perfect square root. Okay? Like, these 2 binomials are exactly the same. All right? Let me give you one more situation here where you have x cubed. Here's another example, right? X cubed plus 25x is equal to 0. Okay? First step I would do is to see, so this is basically asking to solve for x. I don't know how to really do that here, but I know that I could factor out x out of both of these guys. So that's x times x squared plus 25 is equal to 0. Okay, and I could say that this is so now we just got to find out the roots or the numbers of x's that will make this whole thing equal to 0. I'll say x is equal to 0, set that equal to 0, and guess what? That's in itself the answer. X is equal to 0. That's one solution. Here's this one. X squared is equal to, or x squared plus 25 equals 0. So you set this equal to 0 and figure out what x would have to be. And then you'd subtract 25 from both sides. This looks pretty good so far. X squared is equal to 25, right? Which is, you can find that, wait, it's negative 25. Can you take the square root of a negative number? And this should be, no, you cannot. You can take the square root of 25 positive, but you can't do it negative. Because most of you guys would be like, oh, that's easy, Mr. Wade. The x would just be negative 25. But let me ask you, what is negative 5 times negative 5 then? That is not negative 25. That is positive 25. So this is no real answer. So sometimes it might ask you to take the root of, like, the square root of like a negative number. And if that happens, you don't have a real answer. Okay, so that's another scenario that might occur. So those are the types of problems I want you to know for 1-9, 1-10. I want you to practice it during your homework, and hopefully this video wasn't too long. You guys have a great day. Bye.